Good afternoon, students. Is my voice audible?
Yes, sir, audible.
Yeah. Students, we have exam on 10th. So once again, we will revise the first module. After completion of examination, we can start new module. Accuracy. It is the ability of the measurement system to produce true value. Precision. Ability of the measurement system to produce accurate values. Ability of the measurement system to produce repeatedly accurate values. Precision and accuracy are interlinked characteristics of measurement system. Repeatability. The repeatability is the closeness of repeating the same value, same measurement value. Repeatability and reproducibility looks like similar, but repeatability is the ability of the system to produce same value under the same condition in a continuous time periods. But reproducibility is the ability of the system to produce same value for the same parameter under the same conditions at a different time periods. Repeatability and reproducibility are similar, but repeatability is the ability of the system to produce same value in the same time periods, continuous time. Reproducibility is the ability of the system to produce same value for the same conditions for the same parameter at different time periods. Sensitivity, ability of the system to give response for the variation of the physical parameter. Is the speediness of the response in measurement system. Linearity. The linearity describes the closeness between the calibration curve and specified straight line. The dotted line represents expected value. Dotted line is the expected response of the measurement system. Dark line is the practical response curve. Dark line is the practical response curve. Resolution, threshold are interlinked. Resolution is the that is a minimum value that can be measured by the measurement system. And threshold, it is the maximum value which cannot be detected by the device, which is less than resolution. Resolution and threshold are related. Resolution is the minimum value that can be detected by the measurement system. Hysteresis is the disadvantage of the measurement system. Inability, it is an inability to produce same value for the same parameter under the same conditions while we are doing experiment in two ways, that is from high value to low value and low value to high value. Systematic errors that can be detected and then they can be rectified in systematic errors. But in random errors, we cannot detect the exact reason of the errors. We can eliminate the impact of random errors in our measurement calculations by taking average values and by using standard deviations. Dynamic characteristics. Directly, we have taken three types of systems: zero order system, first order system, and second order system. And we have standard input signals like impulse signal, step signal, and sinusoidal signal. After applying those signals, we have analyzed first order, zero order, second order systems. In zero order system, we do not have any energy storage devices, but in first order system, we have one energy storage device and one dissipating device. And in second order, we have two energy storage devices and one energy dissipating devices. In second order system, damping ratio is the main factor to get a response. And we have seen practical examples of examples for first order system, second order system. And we have discussed the sensors. Bimetal sensor is a device to sense temperature. And this is framed by two different metals welded together, which have two different temperature expansion coefficients. And next we have focused on pressure sensors, Bourdon tube, U-tube manometer, diaphragm, and capsules and bellows. We have focused on flow meters. These are the basic flow meters: venturi meter, orifice plate, flow nozzle, rotameter, pitot tube. And these are the massive flow meters. Mutating disc, sliding vane, and a wear channel. We can use a hot wire anemometer also to estimate the flow rate. And next we have focused on level sensors. To estimate force and torque, we have cantilever beam and helical spring, torsion bar. Torsion bar is for torque and remaining two for force. Acceleration and inclination sensors. Gyroscope. This is also for inclination and acceleration sensing. And after that, we have focused on the MEMS and micro sensor technology also. last class, students, I have played few videos to estimate flow velocity by using rotameter and venturing meter. And in this class, I will show you some demo videos to estimate the pressure and force. And this is the final class for the first module revision. And in next class, I will start second module.
We are going to learn about membrane, commonly at the bottom side, is filled with fluid at predetermined pressure, and the other side is filled with the fluid or gas of whose pressure is to be determined. Working. Consider the predetermined pressure as P-REF and unknown pressure as P-EXT. The pressure difference P equals PEXT minus PREF gives mechanical deflection to the diaphragm.
So here, students, you can see it is an elastic type of material we are using as diaphragm.
Membrane deflection is proportional to the pressure applied. By measuring this membrane deflection, unknown pressure can be calculated. There are number of ways to measure this deflection. 1. Use of mechanically coupled indicating needle. 2. Use of LVDT, linear variable differential transducer. When LVDT is used to find membrane deflection, Diaphragm is connected to the core of the LVDT.
Students, LVDT is an electrical device. So here we have two windings. If this core is at the middle, we will get zero output. If core is near to the E2, we will get negative voltage. And if the core is near to E1, we will get positive voltage. Like that, this LVDT is designed. By observing the output, we can estimate the core position.
As you know, in LVDT, there are two secondary coils connected in series opposition, and thus induced EMFs in those coils oppose each other. So the resultant EMF is zero at normal condition. When core moves due to membrane deflection, the flux linking with the one of the two secondary coils increases, which increases induced EMF in that coil. So there exists some resultant EMF. From that, we can determine deflection and thus pressure can be calculated. 3. Use of strain gauge. An electric resistant strain gauge is used to measure the membrane deflection. It has one long resistor strip XY connected to the diaphragm. In that point, X is fixed and Y is movable. As the diaphragm bends, it stretches out the resistor from XY to XY dash. This stretching causes reduction of area of cross-section of the strip and increases its length. Hence, the resistance value of the strip increases. Refer formula R equals rho L divided by A. The increase in resistance causes unbalance in the bridge, which shows indication in the voltmeter. By measuring this voltage value, gauge can calculate the amount of deflection or bend in the diaphragm. Using this displacement, unknown pressure can be determined. 4. Use of other velocity or displacement sensors. Thus, you have learned about diaphragm pressure gauge.
Students, in this video, we will see the working of bellows.
Is applied. measurement of pressure using below gauge. The device consists of the following parts. Inlet A, where the unknown pressure is applied. Bellows made of brass or phosphor bronze. Spring arrangement. Connecting link. Sector and gear arrangement. Pointer needle. Graduated scale calibrated in terms of pressure. Outer case. The bellows are in the shape of an angular ring which are welded both internally and externally. The bellows contract or expand axially depending on the incoming pressures. The expansion of the bellows are restricted by the spring and thereby preventing the full expansion of the bellows. This mechanism will extend the life of the bellows and protects it. Bellow openings should be hermetically sealed such that there is no leakage of pressure. Let us see the operating principle of below gauge. The unknown pressure to be measured is applied at the inlet A. When the applied pressure is low or high, the bellows will squeeze or expand. This moves the link up or down, which is connected to the sector arrangement. The sector arrangement will now react to the movement of the link and the pointer moves over the graduated scale. The readings on the graduated scale indicates the pressure value. When the pressure is removed from the case, then the link should come back to its original position. Let the applied pressure be P1 and the atmospheric pressure of the bellows be P2. Case 1. When P1 less than P2. In this case, the bellows will squeeze or contract. When the bellows squeeze, the connecting link is moved up. This pushes the sector down and the pointer moves over the graduated scale. Case 2. When P1 greater than P2. Under this condition, the bellows tries to expand. When the bellows are expanded, the connecting link is moved down. This pushes the sector arrangement up and the pointer moves over the graduated scale. Below gauge can also be used as an electrical switch. Below gauge is connected to any electrical circuit. When the inlet A is applied with low pressure, the bellows starts squeezing and thereby disconnecting the contact with the circuit. Thus, you have learnt about the below gauge.
Students, in this animation, we will understand the working of nutating disk flow meter. Nutating disk flow meter.
Water flows directly into the meter housing. The water first flows through the meter's internal strainer before it enters the measuring chamber. The strainer protects the measuring chamber from damage due to debris in the water. Inside the chamber assembly is a movable disc that's located on a sliding ball guided by a thrust roller. As the water flows into the measuring chamber, it causes the disc to nutate, a motion similar to a coin dropped on a table. Notice that the disc does not rotate, but rather wobbles on its axis. Therefore, the space formed between the disc and the chamber wall has a constant volume as it moves around the chamber. The water in the chamber is a fixed volume, or displacement. That's why a disc meter is called a positive displacement meter. The smooth motion of the disc has a constant volume as it moves around the chamber. The water in the chamber is a fixed volume, or displacement. That's why a disc meter is called a positive displacement meter.
Friends, if you listen this meter comes under positive displacement flow meter. Nutating disc, positive displacement flow meter.
The smooth motion of the disc also eliminates the annoying noise produced by some other types of positive displacement meters. As this happens, the nutating disc translates its movement through a magnetic coupling to the register. The water then leaves through the outlet port of the chamber assembly.
Students, we have discussed other positive displacement meter, that is sliding vane. Now we can see that animation.
Discrete volumetric segments and precisely measuring this volume in a calibrated measurement section. In this animation, we see a Smith meter rotary vane PD meter in operation. As the transmitter, calibrator housing, and cover with transfer gears are removed, we see
And this is the disc which will rotate.
the heart of the meter, the rotary vane design. The fluid flow enters the meter on the left side. The block at the bottom of the meter separates.
See here, this is the inlet and we are allowing fluid. That fluid is rotating the disc.
The inlet from the outlet and prevents
And here we have outlet. It will rotate the disc and it will come out from the pipe.
the fluid from bypassing the measuring chamber. Instead, it is channeled around the rotor into the measurement section. The fluid is continually separated into discrete segments in the measurement section. The path of a single fluid segment is highlighted in yellow. As the measured fluid segment is discharged from the meter on the right, the rotor cover is removed, and we see the blades rotating around the shaft. The blades are extended and retracted as the blade rollers follow the profile of the stationary cam. The fluid flow drives the rotation of the rotor and blade assembly in a continuous sequence. The rotor assembly is connected to the meter output shaft by a gear coupling. Each revolution of the output shaft, therefore, represents a precise volume that has passed through the meter. The external gear train changes the metered volume into the preferred measurement unit, such as gallons, barrels, or liters. The output shaft can be directly coupled to a mechanical calibrator and counter.
And these are the rotations of the disc. Another important flow meter, students, hot wire anemometer.
Video will discuss about the working of hot wire anemometer. So first we see
Students, in this pipe we have arranged a hot wire. This red color is hot wire, and this is connected to an electrical circuit. So this circuit is called as a bridge. Here the principle is 4 resistors should have same value. Then output will be 0. If any one of the resistor has different value, different resistance, we will get output. By observing that output, we can estimate the variation of the resistance in this hot wire. So here, before allowing the flow, this hot wire has some resistance, which is equal to these 3. When you allow the liquid, because of that liquid flow, hot wire will lose its temperature. And we have to keep on maintaining that resistance by giving the temperature.
see the working principle. Here, when fluid flow over a heated surface, heat is transferred from the
Depending on the flow rate, hot wire will lose its temperature. So this is the construction of hot wire anemometer. Students, next parameter is inclination. Now we will see bubble scale, how to use bubble scale to find out the inclination. See the students, if we change the position of the scale, bubble will take different positions. Here you can clearly observe. Bubble will take different positions in that small cube. So here they have arranged 3 small cubes with the bubble. So if the surface is flat, If the surface is flat, they will take a standard positions like that. Middle one will be middle, and here at the top, and this is also at the top. The surface is flat. Its base is flat. So now, and in this position, that scale and that iron piece is making for 90 degrees. And the last flow meter, that is a pitot tube.
After watching this video, you will be able to and understand about pitot tube and the concept of stagnation pressure. Consider a piezometer tube. Piezometer tube is just used to calculate the static pressure. By measuring the height to which a column of the liquid rises against gravity. The fluid is static, relative to the moving fluid. Hence, it is normally termed the static pressure. The pressure height would be same, considering the flow is steady and incompressible. But what if we replace it with a pitot tube? The column height of the water will increases. And this extra height is called the dynamic pressure, caused due to stagnation pressure. When the water particle enters the pitot tube, its velocity will convert to dynamic pressure. And stagnation pressure is the total sum of static and dynamic pressure. So the stagnation pressure represents the pressure at a point where the fluid is brought to a complete stop. Now let us apply the Bernoulli equation and derive the formula for stagnation pressure. For that, let us write point 1 and point 2. Velocity at point 1 is the velocity of flowing water v, whereas velocity of water at the head of pitot tube, that is point 2, is 0. The datum height z1 and z2 is 0. Now solving the equation with those value we get. Oh, look! We get the pressure at point 2, that is stagnation pressure, is sum of static and dynamic pressure. Now we can measure the velocity of moving water v, if we know the dynamic pressure. And it can be easily calculated by measuring pressure head. Static pressure is same for both points. Whereas stagnation pressure, or the total pressure P2, at pitot tube is same. Please subscribe for more fluid mechanics.
So these are the different flow meter students and different pressure sensors which we have discussed in our subject. And in first module or in semester examinations, you will get questions on these topics. Okay, students, we will meet in next class.